If you think you know Java, you might want to think again. For a long time, let's be honest, it had a certain reputation. But the language has gone through this absolutely massive transformation. So let's dive in and see how Java went from being called a dinosaur to the high-performance dynamo it is today.
Sound familiar? Yeah, this was the common knock against it, that Java was slow, clunky, and just old. But today, that couldn't be further from the truth. We're going to explore the key innovations that have completely reshaped the entire language.
So here's the game plan. We're going to walk through the huge leaps that have totally reshaped Java, from cutting down on all that extra code and completely rethinking concurrency, all the way to a new generation of super fast frameworks.
So, where does this comeback story even begin? Well, it's a fantastic journey of engineering and evolution, taking Java from that so-called dinosaur to the powerhouse it is today.
This slide really just nails the transformation. The old myths you see on the left have been completely replaced by the modern reality on the right. Modern Java is fast, its syntax is concise, and its applications are surprisingly lean and, you know what, even elegant. Let's see how they pulled it off.
First up, let's tackle that infamous verbosity. For years, developers joked about the mountains of boilerplate code Java required for simple things. But there's been a war on that unnecessary code, and the results are pretty dramatic.
The difference here is just wow. On the left, that's the old way of creating a simple data object. It required dozens of lines of code, constructors, getters, the whole shebang. Now, look at the right. A single line. That's a record. This one feature just obliterates a huge amount of boilerplate, letting you focus purely on the data.
And this drive for cleaner code extends to another one of Java's core ideas. It's strict, strong typing. Now that's a good thing, but it used to force you to be painfully explicit. Not anymore.
Check this out. On the left, you can see how developers had to repeat themselves, typing out array list string on both sides of the equal sign. On the right, with features like the diamond operator and the var keyword, the code is so much cleaner. And the crucial part is, the compiler still knows exactly what type list is. It's just as safe, but now it actually looks like a language built in this century. Now for what might be the biggest game changer of them all, concurrency. For years, working with threads in Java felt like operating heavy machinery. There's an old joke that books on Java concurrency are thicker than books on entire other programming languages. Well, that's all changing, thanks to a massive initiative called Project Loom.
The core idea here is the virtual thread. Think of it like this. Traditional OS threads are like big, heavy trucks. They're expensive, you can only have so many. Virtual threads, on the other hand, are incredibly lightweight because they're managed by the Java virtual machine itself. This means you can create literally millions of them without breaking a sweat.
This chart really puts it all into perspective. The resource cost of an old-school OS thread is massive compared to the tiny footprint of a virtual thread. We're not talking about a small improvement here. This is a fundamental shift that enables entirely new ways of building apps.
So what does this actually mean for developers? It means you get to write simple, easy-to-read code that just makes logical sense, but it performs with the efficiency of complex asynchronous code. It truly is the best of both worlds. No more callback hell.
Okay, let's talk performance. The old stereotype of Java being a memory-hungry beast came from the early days of its garbage collector. But just like everything else we've seen, this has been completely re-engineered from the ground up. The original garbage collector had to literally pause the entire application to clean up memory. Those were the infamous stop-the-world pauses. But as this timeline shows, it has evolved dramatically. Modern collectors like ZGC, the Z garbage collector, are designed for incredibly low latency. We're talking about pauses often measured in single-digit milliseconds. For many applications, those disruptive freezes are now just a thing of the past.
And it's not just the garbage collector. The JVM has gotten so much smarter about memory in general. For example, string deduplication finds identical strings in memory and makes them all share the same underlying data, which saves a ton of space. These kinds of optimizations drastically reduce overhead, allowing modern Java apps to run in containers with much smaller memory footprints.
So, how do all these language and JVM improvements actually come together in the real world? Well, they've enabled a whole new generation of frameworks, designed from the ground up for this cloud-native era we live in.
And Quarkus is right at the forefront of this new wave. It's built to leverage modern JVM features, especially something called GraalVM.
GraalVM allows for ahead-of-time compilation, which basically means that instead of running on a traditional JVM, you can compile your Java code directly into a lean, self-contained native binary, a single executable file.
And this is the mind-blowing result of that. A startup time of less than 100 milliseconds. That's not a typo. For anyone who's used to the multi-second startup times of older Java frameworks, it's revolutionary.
What this means for developers like you and me is an incredibly fast and fluid workflow. You can scaffold a project, write standard Java code that feels totally familiar, and see your changes almost instantly. Those long coffee breaks while waiting for your app to restart? Yeah, they're officially over.
So after seeing how far it's come, from leaner code and lightweight threads to instant startup times, the question isn't whether Java is still relevant. The real question is, with this pace of innovation, what incredible things are we going to be building with it next?